The modern automobile is a complex technical system employing subsystems with specific design functions. Some of these consist of thousands of component parts that have evolved from breakthroughs in existing technology or from new technologies such as electronic computers, high-strength plastics, and new alloys of steel and non-ferrous metals. Some subsystems have come about as a result of factors such as air pollution, safety legislation, and competition between manufacturers throughout the world. Passenger cars have emerged as the primary means of family transportation, with an estimated 1.4 billion in operation worldwide. About 1/4 of these are in the United States, where more than 3 trillion miles, almost 5 trillion kilometers, are traveled each year. In recent years, Americans have been offered hundreds of different models, about half of them from foreign manufacturers. To capitalize on their proprietary technological advances, manufacturers introduce new designs ever more frequently. With some 70 million new units built each year worldwide, manufacturers have been able to split the market into many very small segments that nonetheless remain profitable. New technical developments are recognized to be the key to successful competition. Research and development engineers and scientists have been employed by all automobile manufacturers and suppliers to improve the body, chassis, engine, drivetrain, control systems, safety systems, and emission control systems. Vehicle design depends to a large extent on its intended use. Automobiles for off-road use must be durable, simple systems with high resistance to severe overloads and extremes in operating conditions. Conversely, products that are intended for high-speed, limited-access road systems require more passenger comfort options, increased engine performance, and optimized high-speed handling and vehicle stability. Stability depends principally on the distribution of weight between the front and rear wheels, the height of the center of gravity and its position relative to the aerodynamic center of pressure of the vehicle, suspension characteristics, and the selection of which wheels are used for propulsion. Weight distribution depends principally on the location and size of the engine. The common practice of front-mounted engines exploits the stability that is more readily achieved with this layout. The development of aluminum engines and new manufacturing processes has, however, made it possible to locate the engine at the rear without necessarily compromising stability. Body. Fiat 600. Automotive body designs are frequently categorized according to the number of doors, the arrangement of seats, and the roof structure. Automobile roofs are conventionally supported by pillars on each side of the body. Convertible models with retractable fabric tops rely on the pillar at the side of the windshield for upper body strength, as convertible mechanisms and glass areas are essentially non-structural. Glass areas have been increased for improved visibility and for aesthetic reasons. Automobile assembly line. The high cost of new factory tools makes it impractical for manufacturers to produce totally new designs every year. Completely new designs usually have been programmed on 3 to 6 year cycles, with generally minor refinements appearing during the cycle. In the past, as many as 4 years of planning and new tool purchasing were needed for a completely new design. Computer-aided design, CAD, testing by use of computer simulations, and computer-aided manufacturing, CAM, techniques may now be used to reduce this time requirement by 50% or more. See machine tool, computer-aided design and computer-aided manufacturing, CAD/CAM. Automotive bodies are generally formed out of sheet steel. The steel is alloyed with various elements to improve its ability to be formed into deeper depressions without wrinkling or tearing in manufacturing presses. Steel is used because of its general availability, low cost, and good workability. For certain applications, however, other materials, such as aluminum, fiberglass, and carbon fiber reinforced plastic, are used because of their special properties. Polyamide, polyester, polystyrene, polypropylene, and ethylene plastics have been formulated for greater toughness, dent resistance, and resistance to brittle deformation. These materials are used for body panels. Tooling for plastic components generally costs less and requires less time to develop than that for steel components, and therefore may be changed by designers at a lower cost. To protect bodies from corrosive elements and to maintain their strength and appearance, special priming and painting processes are used. Bodies are first dipped in cleaning baths to remove oil and other foreign matter. They then go through a succession of dip and spray cycles. Enamel and acrylic lacquer are both in common use. Electrodeposition of the sprayed paint, a process in which the paint spray is given an electrostatic charge and then attracted to the surface by a high voltage, helps assure that an even coat is applied and that hard-to-reach areas are covered. Ovens with conveyor lines are used to speed the drying process in the factory. Galvanized steel with a protective zinc coating and corrosion-resistant stainless steel are used in body areas that are more likely to corrode. Chassis. In most passenger cars through the middle of the 20th century, a pressed steel frame, the vehicle's chassis, formed a skeleton on which the engine, wheels, axle assemblies, transmission, steering mechanism, brakes, and suspension members were mounted. The body was flexibly bolted to the chassis during a manufacturing process typically referred to as body-on-frame construction. This process is used today for heavy-duty vehicles, such as trucks, which benefit from having a strong central frame, subjected to the forces involved in such activities as carrying freight, including the absorption of the movements of the engine and axle that is allowed by the combination of body and frame. In modern passenger car designs, the chassis frame and the body are combined into a single structural element. In this arrangement, called unit body, or unibody, construction, the steel body shell is reinforced with braces that make it rigid enough to resist the forces that are applied to it. Separate frames or partial stub frames have been used for some cars to achieve better noise isolation characteristics. The heavier gauge steel present in modern component designs also tends to absorb energy during impacts and limit intrusion in accidents. Rentalog electric water technology engine. When water is supplied to the tank, the water flows into a region. The region is blocked by an arc as in your conventional dam. The pressure of the water will increase, the arc opens and the pressure reduces. According to Bernoulli principle, the lower the pressure increases the speed of the fluid water and higher the pressure, the speed, velocity, reduces. The water speed is maintained by Pascal principle, which states the fluid at a point or region is evenly distributed. The water flow into a region of space which passes through a compressed tube-like hole to provide an effective precision entrance to the turbine region, just like in the spark plug in internal combustion engine. The force of gravity of the water will turn the turbine position in an oscillating position as in the flywheel of an ancient dam. The reason is for the water to concentrate in the blade of the turbine for turning purposes. As the water turns the turbine, Faraday law of magnetic field will occur in an alternator-like device as in the case of a wind turbine and the alternator in a car, which is attached at the opposite side via a reduction gear connected by a shaft to the turbine. The turbine is protected via a gate-like channel connected to the alternator-like device. Electric current will be supplied from the alternator at the both side of system and varied by VFD, variable frequency drive, which will act in place of transformer to vary the frequency of the electricity flow, which in turn supplies it to the battery and your home. The air tube is connected close to the water and distributed to a passage channel to prevent overheating. The heat generated by the generator and variable frequency drive will be expelled by heat management system from the device. Little heat will be transferred to the water as a result of heat transfer. This will help reduce the rate at which water is lost from the system. The water from the system flows out through the imperial tube to the reservoir and it is collected back to the tank. This process conserves energy and requires minimum electricity to operate, and also it is efficient. The body of the root system is made of an insulator to prevent escape of electricity. The